In the past year, all of 2019, I had the chance to work on quite a number of high-performance computing and AI deployments for a government department. And the best part of that was having a chance to look at all of these systems at different sizes and for different purposes, and understand what the underlying reference architecture would have to be if we were going to deploy this in a government cloud or a government premises and support protected B data. The architecture that I've come up with is a standard model. Now, surprisingly, although my background is largely in the cloud, a majority of these clusters ended up being deployed on premises. There's a lot of homogeneous structure in these HPC AI clusters, and scale isn't really a big factor. What I am good at is deploying IT systems. So this talk is aimed at the architects and the managers of government departments who are being told by their director that we got to get on this AI thing. So coming off of this talk, you'll have a good idea at a high level of what that's going to cost and how would it work and how would SSC be involved, and how do you look at the cloud and on-premises and decide which is right for you. What makes it easy is that compared to other IT systems, it seems to me all AI clusters have a family resemblance. That's because AI relies upon a finite set of well-known mathematical models and algorithms and so on, and we'll talk about those. To support those models, there are standard software packages that are broadly used within industry and academia, and there are a handful of well-known packages like TensorFlow that we'll be talking about. And those software packages in turn drive a particular set of hardware requirements. In particular, they're going to be requiring graphics coprocessors and numerical coprocessors like NVIDIA. The V100 is the industry standard implementation of that. So there aren't a lot of different ways to assemble an AI cluster. Now, let's start with the standard software packages. I've listed three here that I've had some exposure to. IBM Watson is, I've seen that used in prototype government projects to support knowledge discovery. TensorFlow is the foundation of machine learning and deep learning, as far as I've been able to tell. I've set up TensorFlow deployments in Amazon and Azure for users to experiment with. And OpenAI is another approach, another framework for doing machine learning, and that's an industry consortium supported by Elon Musk. These frameworks are going to, well, especially the machine learning ones, rely heavily on GPUs. So NVIDIA is the industry standard manufacturer of these. That's a GPU up at the top right corner there. That piece of hardware can be bought off of Amazon or through government procurement from anywhere like $6,000, $8,000, $12,000. I've seen higher prices than that, depending on how much RAM and what else is involved. The GPUs are deployed into usually a 1U or 2U rack. That's what that box below is. The motherboard there is going to have a lot of conventional processors. Intel Xeon Gold is kind of the one I've seen a lot of. You might have a ratio of 1 GPU per 4, 8, 16 conventional compute nodes. It's all going to be connected with high-speed optical networking, InfiniBand or NVLink or some of the vendor solutions, and the storage is going to be equally fast. So this is a parallel processing operation where the nodes are chunking up the work, doing it in parallel and exchanging their results at very high speeds. If you package that up for the desktop, this is an NVIDIA DGX 1000 unit. Two of the 8 projects, the low end of the ones that I've been involved with, use this approach. It's one-stop shopping. It's entirely integrated. It fits on a desktop, and it is also not going to support much of a workload. It is good for doing experimental work when you're developing an algorithm, but it is never intended for doing large-scale training of models. The high end of it is something that looks more like this. Now, this is an Australian cluster purchased by CSIRO, their research organization. I use this as an example because they published all of their financial information about it, and I was able to use it as a model for what does an on-premises HPC cluster look like. This one was done in 2017, and I cannot get past the name they gave to the cluster, Bragg. It was a famous Australian scientist, but it also unfortunately explains a lot of the motivation for why people would spend $4 million on a piece of hardware. Bragging rights. You see a picture of me here beside a Canadian equivalent, and I'm smiling because I wasn't feeling the motivation for putting this on premise. However, the economics of this was originally a $3 million cluster. They budgeted another $1 million to support the first year's operation. Now, that's going to cover your utilities cost. These things suck a lot of power. They also require a lot of cooling. Imagine putting 20 electric baseboard heaters in a rack and then filling a room with those racks.